Okay, so we've all seen what a single AI agent can do. And yeah, it's pretty impressive. But what happens when you need more than just one? You see, the real power isn't in a solo act. It's in a whole AI workforce. Today, we're going to dive into how to build and orchestrate that team, moving from just a single agent to a fully coordinated system of specialists.
And that really brings us to the big question, right? It's one thing to have a powerful billing agent, but what if it needs to talk to the fraud agent, who then needs to loop in compliance? How in the world do you get them all to collaborate seamlessly without just creating a total mess? That's the core challenge we're tackling today, orchestrating an AI workforce.
So here's our blueprint for this explainer. We'll start with orchestrating the team, then we'll break down 3 key patterns: the agent handoff, parallel workflows, and how to add human oversight. And then we'll put it all together to build out a complete production system.
So let's get into it. Team orchestration. This is where agentic AI starts to get really interesting. We're moving way beyond just single-task agents and into a world where a whole team of specialists can work together to solve complex, multi-step problems.
First up is our absolute core pattern, the agent handoff. Honestly, the best way to think about this is like a relay race. It's all about how one agent can pass the baton, the work and all of its context, to the next specialist, dynamically without missing a single beat. Let's look at how this works in practice. So a request comes into the billing agent. It spots something a little suspicious in a transaction. Now, instead of just stopping, it intelligently hands the entire case, context and all, over to the fraud agent for a deeper look. Then that agent might pass it to compliance. See that? It's a clean, sequential flow of expertise. So if we're going to put a formal definition on it, an agent handoff is a dynamic routing pattern. And trust me, dynamic is the most important word here. It means the connections aren't hard-coded. The agent itself decides where the work needs to go next, and it transfers the full context so nothing gets lost in translation.
And the magic behind this? It's surprisingly simple. It really just comes down to one line of code. When an agent decides it's time to escalate, it just returns a command object. This is basically an instruction for the whole system, telling it, hey, my job is done, send everything over to the fraud agent to continue. That's it.
So the really crucial point here is understanding why this is so much better than static, predefined workflows. First, it's dynamic. The LLM makes the routing decision in real time. It's stateful, which means the fraud agent gets the entire history, not just a snippet. It's auditable for compliance, and it's incredibly scalable. You can add a new retention agent tomorrow without having to rewire your whole system. It's a game changer. All right, so handoffs are perfect for sequential tasks. But what if you need speed? I mean, real speed. Well, that brings us to our second pattern, parallel workflows. This is all about tackling multiple parts of a problem at the exact same time to get a resolution fast.
Just imagine a supervisor agent gets a complex request, maybe to analyze a customer's churn risk. Instead of a slow, linear process, it can fan out the work. It might send a task to the billing agent to check payment history, and at the exact same time, send another one to the network agent to check for service issues. They work in parallel, their findings get merged back together, and you could literally cut your analysis time in half.
And just like the handoff, this whole thing is triggered by a really simple command. The supervisor agent just returns a command that tells the system, okay, kick off these next tasks at the same time. It's a single instruction to branch the workflow out into multiple parallel streams. Now you've got a few ways to pull this off, and this table breaks down the trade-offs. You could use a super powerful framework like LangGraph for stateful, auditable graphs, which is perfect for production. For faster prototyping, something like CrewAI can be simpler. And for just pure raw speed, you can use a standard library like Python's asynchronous, though you'll have to manage the state yourself. The main takeaway here is you've got to choose the right tool for your specific job.
Okay, on to our third and, arguably most critical pattern for any real-world application, adding human oversight. Now, this isn't about slowing things down. It's about building an absolutely essential safety net that ensures compliance, builds trust, and prevents really costly mistakes.
We call this human in the loop, or HITL for short. The whole idea is to strategically insert breakpoints into your workflow. So before a high-stakes action, like handing a case over to the fraud team, the system just pauses. It waits for a human to give the green light. For things like financial transactions or telecom fraud, this is completely non-negotiable.
And what's so amazing is how simple this can be to implement in a framework like LangGraph. You just add this one little decorator @interrupt before a specific node in your graph. In this case, we're basically saying, always pause for human approval right before the fraud agent is allowed to run. It's an incredibly powerful safety feature packed into a single line of code.
All right, this is the moment we've been building towards. We've learned about handoffs, we've learned about parallel work, and we've learned about human oversight. So now let's combine all three of these patterns into a single, sophisticated blueprint for a real-world application: telecom fraud detection.
This workflow right here is our masterpiece. It pulls everything together. You can see it starts with a supervisor planning the work. Then it uses those dynamic handoffs to move the case between billing, fraud, and compliance specialists. And critically, you can see the HITL gates, those human checkpoints, ensuring every major escalation gets approved by a person. This is what a robust production-grade system looks like. It's both autonomous and safe.
So let's trace the flow together. A case comes in, the supervisor plans the initial steps. Then, the billing agent detects an issue. But, and this is key, before it can hand off to the fraud team, the process pauses. That's our first HITL gate, waiting for a human's OK. Once approved, the fraud agent investigates. If it finds a high-risk pattern and needs to escalate to compliance, the system pauses again. That's our second HITL gate. Only after that second sign-off does the compliance agent get the case. You can really see how all these patterns interlock perfectly.
Now, you might be thinking all these human checkpoints would slow things way down, but look at this number. This system actually achieves a 92% auto-resolution rate. This just proves you can build in safety and oversight without killing your efficiency. The vast majority of cases get handled automatically, with humans only needing to step in for that tricky 8% that are truly ambiguous or high risk.
And this quote, pulled directly from real-world project notes, makes this whole thing incredibly concrete. This isn't just some theoretical design. It's a pattern that has been deployed in actual production telecom projects, and it's achieving that exact 92% auto-resolution rate through this combination of billing analysis and intelligent handoffs.
So as an architect, this is your final decision framework. You're always balancing speed against reliability. For low latency needs like a real-time billing check, you'll probably choose fewer steps, a smaller model, and parallel execution. But for high reliability stuff like a deep fraud investigation, you'll want more reflective steps, a larger model, and a sequential, stateful graph probably built in LangGraph.
So we've covered the core patterns for building a really sophisticated AI workforce: dynamic handoffs for expertise, parallel workflows for speed, and human-in-the-loop for safety. You now have the blueprint to go from a single agent to an entire orchestrated team. So the only question left is, what will you build first?